I'm going to talk about a short project I've been working on recently, and this is using Docker containers in bioinformatics. So recently I've been putting bioinformatics software inside of Docker containers. So if you think of this as the Docker container, then I put some piece of bioinformatics software in here, and then I give it some data, and then I get some data out on the other side. Like so. And the aim of this is, if I have, say, some pipeline, say this is my data here, and I want to get, and this is my output, if I find out that, say, this container here is not working very well, so the container I'm using is not working very well, and I want to be able to, I want to actually replace it with another one. So for example, I have another container here. If you say this container also contains similar software, then what I want to be able to do is just get rid of this one with this piece of software, and then just slot a different piece of software in here. Now the problem with this is both of these pieces of container, so this container and this container, for me to be able to slot them in and out, they both need to have the same interface. So for example, if you might visualize this as saying, say for example, if I do choose red, they both need to say take data in here and put data out here in the container if you visualize it this way. Now the problem is, if say for example this container, it doesn't instead of having taking data in here, it takes it in up here, and then it means that I can't just slot it in and out, because my current workflow, it takes data in and here, but the whole is up here instead. So what I need to be able to do is I need to be able to ensure that all the containers work the same way. And so the way we've been working on this recently with myself and some collaborators is a project called Bioboxes. And what we do is we define a spec whereby we say that if you write a Docker container for a piece of software, it has to behave a certain way. And we can go to, say for example, the short read assembler. This is the spec for a short read assembler, and here we define what the input should be and what the output should be. Now that's good, but again, how do we test it? So going back to here, what I've been working on, and what I'm going to show quickly here, is say for example, I have my genome assembly container. So this is the one that has my piece of software in. What the project I've been working on is to write a second container that tests the piece of software. So you have a second container, and if you give it this container, it will test it and make sure it works. And the way it does that, if I just erase this here, is the second container, it's a container which you put your other container inside. So if I draw this around here, rough drawing, so you have an outer container, this one here, which builds a version of the container you want to test inside of itself, and then runs the inputs in and out to make sure that they work, and it either tells you if it passes the spec or if it fails the spec. And so this is what I'm going to give a short demo of now. And so to use this, what I've written so far is relatively simple. So this is the script here. All it is a Docker run with the privilege flag, and you mount a volume that contains the Docker file and everything it needs to build the container you want to test. You specify the name of the image as part of the environment, and then that's it. And so I can give an example here, script test, and this will start building it. And I'll pause the video now because this is going to actually build the test container inside the validation container. So I'll pause it now. So you can see here it's just finished, and so everything up here is the output of the container being built, and then these lines here are the output of the container being tested. And so I'll go through how that works now. So this, first of all, is the Docker file of the outer container. So this one here, the outer one, is the Docker file. And you can see what this is doing. It's installing Docker here and setting up a Ruby environment and some gems, and then setting up Docker in Docker. And Docker in Docker is a project developed by Jerome Petazzo. And you can see here, what this basically does is it allows you to run a Docker daemon inside of another Docker container. And so that's what I've based this project on. And so that's what allows an outer container to run a container inside of it. And so this is the Docker file to set that up. And so the entry point is that wrap to Docker command. And then the command that gets run is root run. And so if I look at this here, and that's very straightforward. It just makes sure that a image is defined in the environment. If the directory build exists, then it builds the image. So that's if you want to do on a short feedback cycle where you update your image, run the validation and test it again. And then all it does is it execs Cucumber, which is a Ruby framework for testing. And then all this does is it runs the command, the Docker command, and then makes sure the exit status is 0, and a context file is generated, and the context file matches the expected format. And this is relatively simple and very experimental, but the aim of this is to show that we can validate scientific software and make sure it behaves as you expect. And I can just prove it works finally. So if I go to my assembler and I deliberately break it, so say I delete this command here, so it doesn't copy to the output file, the environment variable, and I now go back down here and I rerun that test script again with the broken assembler, with the broken piece of software, pause it while it builds, and this is just finished. So if I look at here, you can see that the test got run after the container was built, and you can see it failed here. It says it's failed, and it's because the file context should exist and it didn't exist. So that's it, an experimental method for validating scientific software using containers that test containers.